We have a great set of presentations today. First from Dr. Marc Meyer and second from Dr. John Williams. They'll each give a presentation of about 20 minutes, and again, we'll have 8 to 10 minutes for questions from the audience afterwards. Now, I'd like to introduce our first speaker, Marc Meyer, who'll be telling us about the post-fire restoration framework for national forests in California. Marc is an ecologist with the U.S. Forest Service Pacific Southwest Regional Ecology Program and serves the Inyo, Sequoia, and Sierra National Forests. His work focuses on integrating science information into land management planning and ecological restoration projects in the Southern Sierra Nevada. So without further ado, I will pass the presentation over to Marc.
Thanks, Allie. Good afternoon, everybody. Glad you can join me today in my presentation on the framework for post-fire restoration in California's national forests. This is very much collaborative work between a number of individuals, primarily within the Region 5 Ecology Program of the Forest Service and the Pacific Southwest Research Station, also with the Forest Service, and other colleagues in Region 5. Many of you are quite aware of the predominant wildfire trends in California. What we're seeing are that wildfires are becoming larger, more frequent, and severe in many of our California forest and other ecosystems. As a consequence, we've seen a substantial loss in forest and woodland ecosystems and the ecosystem services that they provide. The key question really I'm going to pose is, can we effectively restore these post-fire landscapes? What I would argue is that our current approach on our national forests within the state are pretty limited. And they're limited for a number of reasons. One is because they often rely on a fairly narrow range of management objectives. These might be fuel reduction objectives, other objectives that, such as maintaining forest cover, which are important objectives, but they don't necessarily meet the larger and diverse intent of our current forest plans or revised forest plans and a lot of our new management direction related to ecological restoration in our national forests in the state. Secondly, many of our current approaches are largely tactical and conventional in nature. I would argue the approaches, for example, tactical approaches of reforestation, salvage harvest to produce conditions safe for reforestation, for example, and reduce fuel loading. These approaches can be pretty effective, but when these actions are not placed in the proper context and we're not aligned with the current science, they can be pretty limited in their effectiveness across a larger landscape. And then related to that, our management actions in many of these projects appear to be pretty poorly limited to our landscape scale restoration objectives. So it's not exactly clear what may occur at a stand scale or local scale, how that contributes to our larger landscape scale objectives in terms of restoring that overall forest or other landscape. And these are just a list of few of these limitations of our current approaches. This is what brought many of us together to try to develop a new approach that really looks large scale, more strategic at these landscapes. And there are several components, I think, of a new approach that would make post-fire restoration more successful across these larger landscapes. Now, perhaps most important and obvious is that we need to look at landscape scale. We need to look at it strategically across these larger landscapes to link our management actions that occur at a local scale to these overarching restoration goals and objectives that occur at the landscape. Secondly, it needs to focus on long-term recovery. Many of these actions might just be ones that we implement in the short term, but we need to think long-term, not just years, but decades into the future, especially within forest ecosystems, to achieve many of those restoration objectives in the long term. Thirdly, I think we have to look more broadly at the different fire effects we're seeing in these landscapes. We often hone in and focus very much on where we see the negative fire effects, especially the most extreme negative fire effects of a fire on a burned landscape, and we completely ignore or largely ignore the positive or neutral effects of those fires. Those are missed opportunities when we think about restoration in these landscapes. Fourthly, we need something that facilitates integrative and creative approaches and thinking within these landscapes. And lastly, and certainly not least, is to explicitly think about climate change and climate change adaptation in these landscapes. How do we integrate climate change better and adaptation to this stressor as it interacts with other stressors in these burned landscapes? So with these kind of thoughts in mind, there were about 24 of us, over 5 years ago in 2015, that got together in the fall of 2015, and then regrouped again in another workshop in 2016 at the Natural Areas Conference in Davis, California. The initial meeting was in Wildland, California, in Yosemite National Park. And we got a pretty diverse group of specialists together in the Forest Service. They included research and management sides, but they included groups for, represented everything from fire and fuels to vegetation, to botany, wildlife habitat, soils, and the list goes on. We tried to gather this diverse group together to kind of gather all these different perspectives on how you might approach post-fire restoration from a strategic standpoint. And our goal was to develop a science-based framework for post-fire restoration under national forests in California. So this overarching framework that focuses not just on forest ecosystems. A lot of our focus in recent years has been on coniferous forest ecosystems, but there are a diverse array of vegetation types in the state. So recognizing some of those other types that are pretty predominant, especially we get to the coastal and southern parts of California, of these shrubland ecosystems. So we really focused also on the shrubland ecosystems, chaparral, sagebrush steppe, for example. And I'm very pleased to announce and say that we did finalize our framework in this General Technical Report 270, which we published just a couple of months ago, and it's currently available online. Just briefly, I want to touch on the General Technical Report elements. It essentially starts with a background where we came from in our thinking about the purpose, need, and scope of this framework. Several guiding principles, which are in Chapter 1, which I will describe in a subsequent slide. We went over a 5-step process. This is the kind of meat and potatoes of our framework. It's what we call the restoration framework itself, and I'll go over this, and this is the bulk of my presentation today. And there are 3 case studies in the GTR focused on mixed conifer forest, chaparral, and sagebrush steppe to illustrate how you'd apply the framework in these different landscapes in different parts of the state. And then lastly, we have a variety of appendices that go more into detail about spatial analysis tools, relevant spatial data sets, and other important information that goes into much greater detail about how these tools and data sets can be applied or used and where they're available and so on. So this slide that I'm showing you right now is really, it provides a simplified example of our restoration framework. It's essentially that we have 6 guiding principles, and I'll go over these briefly. They include such things as restoring key ecological processes. These are restoring our natural fire regimes, for example, considering landscape context, and thinking just, within, besides just the burn perimeter, we want to look at the larger landscape that might be directly or indirectly affected by the fire. So even including those unburned areas adjacent to the fire, promote regional native biodiversity, sustain diverse ecosystem services, establish a prioritization approach for management interventions, and lastly, to incorporate adaptation to agents of change, including climate change. These 6 guiding principles serve as the foundation of, and these are guiding restoration principles, serves as the foundation for our restoration framework. The 5-step process I'll go over in a minute. And this restoration framework, the outputs that come out of that is what really feeds into developing projects, planning projects, and implementing them within a burned landscape. And of course, it's always important to mention how monitoring, besides being important to monitor the effectiveness of our various treatments, can also be helpful for whether we need to go back and reevaluate the landscape condition through our framework process. So let's delve into some of the details of this. This restoration framework is essentially this 5-step process. I'll go step by step here. So step 1, what you do is you assemble an interdisciplinary team. You identify priority resources, desired conditions, and restoration goals. Seems pretty simple, but it's something we explicitly need to do in the very beginning to get a good sense of what our overarching restoration goals and objectives in our landscape are. And many of these desired conditions, priority resources, and goals can come out of our forest plans. They could come out of other natural resource documents. They could be conservation strategies for specific species. But whatever the team decides is most important, we pull that information together and use that to go to step 2, which is gather and analyze relevant spatial data. The spatial data can consist of a number of sources based on that first step. And I'm going to go over to this second step a little bit more detail. This is, I think, our chapter 3 in our GTR. So the data gathering analysis phase consists of these 3 steps. In essence, you'd assess post-fire ecological condition by gathering spatial data related to pre-fire vegetation, fire effects data such as vegetation burn severity data, and priority resources. These could be species of conservation concern or whatnot that are of particular and keen interest in your landscape. Secondly, you consider other factors that may influence post-fire recovery. These could be other stressors such as climate change, exposure data layers, invasive species occurrences, and so on. And thirdly, you'd incorporate additional analysis tools. And there's a variety of these tools that are currently in development, and there'll be more in the future. One example that I provide in this slide is the Postfire Conifer Regeneration prediction tool. This is PostScript, a tool that allows you to predict or provide a predictive model of where you might see conifer regeneration occurring and or not. This slide illustrates a real simple version for of some of these spatial data overlaid with one another in our mixed conifer case study. I believe this is chapter 4 of our GTR, and it uses the 2015 rough fire that burned on primarily on the Sequoia National Forest, Giant Sequoia National Monument, but other lands as well. And this was about a 152,000 acre fire that you could see here outlined in black. The different colors, of course, indicate different vegetation burn severities. Red and high severity indicates high severity. Green indicates low severity, and so on. And then we have our priority resources, such as giant sequoia groves, outlined in blue, and our Fisher potential habitat. Fisher is a species of conservation concern in this area in the polygons that are dashed in this landscape. So we can begin to pull these different data layers together to get a visual of these overall fire effects in the ecosystem vegetation condition within this landscape. Then we can pull our various spatial data layers from other outputs, such as the PostScript tool I mentioned earlier. Shows you here, it's really demonstrating areas where you might see a conifer in conifer forest, conifer regeneration occurring, natural regeneration areas in that kind of aqua color, or areas where you have a high probability of natural conifer regeneration. Warmer colors indicate low likelihood of natural conifer regeneration. So pulling this information begins to allow us to have that better picture of what's going on. Then once we pull these data layers together and we've reviewed them, we move on to step 3 in our framework, which is to use the post-fire flow chart to identify what we call restoration opportunities. So let's delve into this one, third step, in a bit more detail. The post-fire flow chart simply starts off in that top box by asking this question: where did fire effects improve or maintain ecological conditions? And where are fire effects within the natural range of variability, or NRV? We can easily substitute NRV for desired conditions from a document like our forest plans or whatnot. But the basic idea is we're trying to distinguish areas where fire had a positive effect or neutral effect, and that leads you to the left side of the flow chart, where basically conditions were improved or maintained, fire effects burn within the natural range of variability, or on the right side of the figure where conditions lead to degradation, where you are departed from NRV or desired conditions. As in this slide I'm showing now, this is what we used in our mixed conifer case study in the rough fire. We basically looked at fire severity within our coniferous forest types and quantified areas that burned within the natural range of variability. These are areas that burn primarily at low to moderate severity or small patches of high severity. For areas that are in yellow to red are moderately or extremely departed from the natural range of variability. Think of these as our larger high severity patch sizes. These can be linked to our natural range of variation assessments or our forest plans. But the basic idea is, as you get to those larger high severity patches, I believe the extremely departed is over 100 hectares or over 250 acres in size of high severity patches. These are the areas where we are more departed, and we're seeing negative fire effects in this burn landscape. So going back to our post-fire flow chart, those areas in green where we say primarily the low to moderate severity fire effects, we would be asking the question in box A, where do other factors threaten ecological resilience and sustainability? And where other factors are present, once again, this could be excessive climate exposure, the presence of invasive species, or other factors are present, even though we saw primarily beneficial or neutral fire effects, we might end up on the right side of the flow chart, which I'll go over in a second, if those other factors, stressors are present. If, however, the interaction of these stressors between the effects of the fire and these other stressors are primarily absent, then these we consider to be areas at low risk, and that would lead us to the box at the very bottom left, where we would want to maintain and promote those desired conditions. So fire is beneficial, let's maintain and promote those conditions into the future, not just into not during the present. So that's our first, what we call restoration opportunity in that first box. However, if we end up on the right side of the flow chart, these are, remember, these are areas that are degraded due to severe fire effects or things that we see outside the natural range of variability. We end up, or if there's this interactive effect of the stressors from box A, we'd end up at box B, where we'd ask this question: where are management approaches feasible for the restoration of desired conditions, given current and anticipated future conditions? And if there are management approaches are feasible and desirable, we'd end up at that restoration opportunity in the lower middle box, we call box 2, take management actions to restore desired conditions. So these are the areas where we might want to reintroduce fire, use prescribed fire, reforestation actions. There are a variety of different actions we could take there, but the basic idea is those are areas where we could take management actions to restore those conditions. However, in box B, if we say no, those areas are not really feasible to restore desired conditions, and there's a number of reasons why this could be the case. They could be inaccessible to equipment and personnel. They could be areas where we just know, based on our future climate data, coupled with other stressors, that conifer cover, for example, is very unlikely to persist into the future. We might want to manage these for new desired conditions. So we fall in this category we call box 3, reevaluate desired conditions considering climate change and other stressors. And these could be areas, as an example, where we have conifer forests unlikely to persist into the future following the fire for one reason or another. And so we're going to manage them for another vegetation type. That might be hardwood forest or hardwood stands, or could even be a shrub dominated system. But the basic idea is that you end up with one of these 3 restoration opportunities at the bottom of the flow chart. And I would really emphasize that our current approach, or more traditional approach that we've had in the past, really focuses in on those areas in box 2 to take management actions to restore desired conditions. We often neglect or put aside or forget about those areas where we had beneficial fire effects to maintain or promote those desired conditions, or to what I think is a pretty novel thought process is to try to reevaluate the desired conditions to consider climate change and other stressors. This is something that I don't think we often do in our post-fire restoration planning and implementation. So now that we've gone through step 3 in some detail, we proceed with our last 2 steps here in our restoration framework. That includes step 4, which is to develop and integrate restoration opportunities into potential restoration actions. And lastly, to build a restoration portfolio by prioritizing those actions. And I'll go over this in just brief detail here. Oops. So a restoration portfolio, think of it as a suite of potential restoration actions where we group them together, and we have several considerations for these. They include such things as feasibility, how likely are they to be implemented on the landscape, what the timing of those actions are. Is this something that's really a short-term action, the next year or two, or we think in midterm or long-term, 3-5 years out or even more? So that's another consideration. Lastly, can we integrate these individual actions so that they're more effective or efficient when they're grouped together than as applied alone? So once you take all of these different considerations into effect, we can then group those actions based on those considerations into one of those, our 3, what we call the restoration opportunities I illustrated on the flow chart That is, maintain, promote desired conditions, take management actions, or to reevaluate your desired conditions. And it's worth noting that you can have the same action, such as applying prescribed fire, in more than one of these categories, or monitoring. And some of them might just be applied, such as reforestation, to a single one of these, but they're not necessarily mutually exclusive. And then lastly, once we've identified, grouped these restoration actions and then place them in one of these categories, we can spatially define and field refine each of these based on field data and information in our spatial output. So let's show these in a couple formats. One, this is taken from our mixed conifer case study in our GTR. This is really an abbreviated version that's much more detail in the GTR for this example and the other case studies. But just for illustrative purposes, here we have our 3 restoration opportunities that I just described on the left side of the table. Maintain, promote desired conditions, take management actions to restore them, and reevaluate the desired conditions. Each of these has an associated target area, management action associated, or set of management actions, the timing associated with each of these, their feasibility, and what we like to call the cost of inaction. So if you don't take those actions, what is the cost of not doing that? And we can summarize these all in a tabular format to better see to group these and better see the larger overall portfolio picture of how we might apply these restoration actions across the landscape. And then we can also illustrate these in a map. What we call here is the restoration portfolio depicted spatially, where you'd want to maintain, promote the desired conditions shown in orange. Those are the areas, remember, that burned at low to moderate severity, beneficial fire effects. Maybe 10, 15 years down the line, we might want to reintroduce fire again into these systems where fuels accumulated again with prescribed fire. The areas in that kind of orange, brownish color, you reevaluate desired conditions. These might be areas that are converting from forest to hardwood stands, and we might want to facilitate that or simply allow it to occur. Thirdly, you see the areas colored in aqua color. These might be areas to take management actions, such as using prescribed fire. So these are the areas that burned at high severity, maybe our large high severity patches, but we might want to continue to reduce fuels to protect some high value resources and assets in those areas by reintroducing fire and using other fuel reduction methods. And then lastly, the areas in blue might be areas to use reforestation techniques in order to reestablish coniferous forest cover where it's unlikely to occur, but where it could still persist into the future. It just requires some management actions to make that happen and let conifer cover persist. So that's basically the restoration portfolio. And there's, once again, just a simplified example, but you can add a variety of different restoration actions in this portfolio, depicted tabularly or spatially. So in summary, hopefully I've convinced you in this presentation that this is what we've outlined here in this framework. It's really a process. It's really a way of trying to rethink and shape your thinking about how to strategically approach post-fire restoration in our large and severely burned landscapes. It's really designed to encourage you to think more broadly, creatively, and strategically about these landscapes, to explicitly link your individual actions to landscape scale restoration goals so that those really are tied together. To identify areas where you'd want to, first of all, maintain, secondly, restore, and thirdly, reevaluate your desired conditions in a restoration portfolio format so that it's easy to follow and understand. And so a lot of those individual actions, once again, can be linked to those larger goals and objectives. And I also want to stress that we don't go into this too much detail, at least I didn't in the presentation. We go more detail in the GTR, but there's really a lot of opportunities for integrating new spatial and other analysis tools and spatial data in this process. And we go into some detail in the GTR. But the idea here is that this is really a process. It's not a set of spatial data. It's not a set of tools. It's a way of pulling those decision support pieces of information and tools together so that you can better apply and plan for restoration within these large and severely burned landscapes. So with that, I will stop. Just acknowledge a couple of funding sources here, like the Joint Fire Science Program and the U.S. Forest Service Pacific Southwest region for their support and funding. And yeah, with that, I'll just say thank you very much for your attention, and I guess I'll take any questions.
Great, thank you, Mark. We've had a few questions come in, so I'll read those out for you. Our first question comes from Stacy Frederick. She's wondering, when you went through this process, where did the biggest data or information gaps often exist?
Yeah, great question. I think when we first delved in this, it wasn't so much that we ran into that issue of information or data limitations. It was more getting our head over around the process and trying to develop the framework so that it really suited the needs of everybody, and also was something that was intelligible and something you could easily follow, whether you're a researcher, a manager, a stakeholder, or whatnot. Now, given that, to maybe more directly address your question, I think when we first embarked on this, there were a lot of analysis tools that were not available at the time. We didn't have Postscript, for example, finalized. We didn't have some of these other reforestation. I know I'm beginning to see a lot of reforestation decision support tools being developed. I'd say that was one example where we just didn't really have much information, but we were beginning, we knew that that sort of information was coming online soon. So we knew we were going to need to find a way to fold that information in. But there, if you want more details on this, I'd encourage you to go to the, I forget, it's chapter 7 or 9 or something like that, where we talk about some of our limitations and caveats to this GTR. And it goes into some detail, a little more than I would hear in the presentation, but it goes into some detail about some of our data set limitations, like pre-fire data, our limitations of, when we use the NRV concept, what some of those constraints and limitations are. So there's a variety of those in whatever you take, but the overall, the framework still, I feel like still provides a nice structure by which to think about how to begin to restore these landscapes, which are quite varied in the state.
Great. Our next question comes from Robin Derbyshire. Have you considered using the terrestrial condition assessment in the post-fire flowchart to assess other stressors or to identify areas where restoration is not feasible?
Yeah, that's another good question. I think there's two ways I can answer this. I think the terrestrial condition assessment can have a lot of value. I think in when we're looking at some of these larger scale patterns across the bioregion or within individual national forests, I think, at least my initial read of it, and maybe I need to delve into that information more, but my read of it was when you start to get into the finer details of vegetation change within these landscapes, and some get to be pretty large in these fires, is that data set didn't seem to have as much utility when we started to delve into the really finer spatial data layers. Now that said, I think as our fires get larger, more severe, especially larger, data sets like that start to become more appealing or start to become more informative. And so I would also say that data sets like that, which I imagine evolve as time goes on, all of these could be useful pieces for that assessment, that spatial assessment phase that I described earlier in my presentation. So there's no reason you couldn't pull that information in. An interdisciplinary team can just pull that information in and look at it and use it to help, once again, refine and develop some of these, develop your restoration portfolio. So I see it, and although maybe initially I didn't see the utility of it at the smaller spatial scales, I don't see that that necessarily is something that would limit somebody else who might be interested to pull that information in to try to evaluate its utility and its usefulness in the framework.
Okay, thank you. Another question from Robin. How does your process link back to the forest plans? Places where you reevaluate the management objectives may need to have a forest plan amendment if those objectives alter the outputs of goods and services from the existing forest plan.
Yeah, great question. And one I actually can answer because I'm on the forest plan revision team for the early adopter forests for the Inyo and Sierra and Sequoia National Forests. So there's a couple ways to answer that question. One is I've worked with the planning team to develop a forest-wide goal, which is, for those not familiar with the planning lingo, it is a planning component that really is focused on an overarching goal of the forest to try to, especially with partners, to try to achieve what's laid out in that statement and that goal. And that goal is really focused on post-disturbance landscapes, especially burned landscapes. And we very much tied that to the process laid out in this framework. So to develop a restoration strategy for a landscape burned in these really large and severe wildfires, and tying that to very much some of the other components in the forest plan, especially the desired conditions. And I've given this a lot of thought, and one way that, it's easy enough, I think, to tie that to areas where you can say desired conditions were met, that first restoration opportunity, and even areas where in that second restoration opportunities, desired conditions, it's, negative fire effects, departed from desired conditions, restore those, right? Those seem pretty straightforward. You can tie those to the plan. And we have some, excellent plan components, I think, that really help guide managers as to when you can achieve those or not. But it's really that third restoration opportunity that was a bit of a head scratcher for me. When you're departed from them, you can't just, have a, like I insinuate, you can't just do a plan amendment, or I guess it would take a long time if you tried to do that. But what we did in the plans was carefully frame the language so that if you did have a fire that burned in let's say a coniferous forest stand, and that conifer forest stand was not going to reestablish in the future, because despite as much effort as we might put into it in terms of reforestation and other things, that climate change and other interacting stressors might have other things to say about that particular piece of land, that it might just convert to another vegetation type. And so I've drafted and crafted language in the plan so that they specifically, and I forget the exact language, but they specifically point toward managing for those desired conditions, even if it means conversion to a new vegetation type. We now manage it for those other desired conditions. So I think even in the current forest plans, there is sufficient wiggle room in each of those to be able to say, you know what, we're managed for this type, but these systems are not static. We've never known to be static, even without considering climate change. So now they can convert to another type, and we can actually facilitate or realign those conditions to those new vegetation conditions that, given they provided maybe a different set of ecosystem services, but they're still valued services for our public and for our stakeholders and everybody. So I like to think that that we've done the due diligence and linked the plans thoroughly to what's laid out in this framework.
Okay, thank you, Mark. And thanks again for your great presentation. In the interest of time, we're going to switch over to John's presentation, even though we do have several other good questions to ask you. We'll see if we have time at the end to come back to any of those. So our second speaker today is John Williams, and he'll be telling us about the California Prescribed Fire Monitoring Program. John is an ecologist and project scientist at the University of California, Davis, where he manages the California Prescribed Fire Monitoring Program and studies the effects of natural and prescribed fire on forest ecosystems. He also conducts research on climate change, species distributions, biodiversity conservation, and the interface between agriculture and natural habitat. So without further ado, pass it over to John Williams.
Thanks, Allie. And it's kind of nice to follow Mark because he gave some immediate examples of how prescribed fire can fit into some of the management and ecological restoration goals that he's dealing with. Anyway, I am the project scientist managing the California Prescribed Fire Monitoring Program. It's a collaboration between UC Davis and the Fire and Resource Assessment Program at CAL FIRE, as well as with support from the California Air Resources Board. There's a whole bunch of people, especially at UC Davis, that are contributing to this, and I'll give them a nod at the end there. But basically, the program is it's a 3-year pilot project started in June of 2019, working especially with CAL FIRE and a whole host of partners. And here are some of the partners listed that we're working with. And it basically came out of a combination of this sort of the past trends of wildfire in the past 20 years, not just in terms of large wildfires, but also these wildfires that are extreme, high percentages of high severity fire. And so this is an example of the King Fire in 2014. And so normally a wildfire, A, wouldn't be this size, and B, would have about 10, probably somewhere between 5 and 10% of high severity, which is that color in red. And you can see this is well over 50% in the King Fire. It was also that way in the Rim Fire that Mark showed. And so these conditions and trends precipitated a number of pieces of legislation and some government California task forces that prompted CAL FIRE to look into establishing a long-term monitoring program, and so we can understand how prescribed fires is working on the landscape and whether it's achieving its objectives of risk abatement for wildfire, but also of the ecological restoration. And so on the ecological restoration side, you can see this is just looking at the Sierra Nevada Southern Cascade region, but you can see how an increasing trend for the amount of acres burned in wildfire over the past 30 years is still well below that dotted line up high on the left-hand graph, of which was how many acres are estimated to have burned in pre-Euro-American settlement. So it's prior to about 1850. And on the other side, we see the sort of the climate effects of how drought, for example, is affecting tree mortality in the same regions, the Sierra Nevada region. And the darker the sort of the orangey and redder the colors, the more trees per acre that are dead, as well as sort of this increasing development of the wildland urban interface, or the WUI, where people moving into this area basically making more interaction between people and forests and ignition of wildfire. So that's sort of the genesis of the program, and then its goals basically is prescribed fire as one of the principal tools in the toolbox of how to address risk reduction for wildfires, as well as ecological restoration. So in terms of risk reduction, we've got these what were previously fuels limited systems becoming ignition limited systems after 100 years of fire suppression and exclusion. And so prescribed fire is reducing those fuels and disrupting some of the continuity, fuel continuity that leads to these large scale and high severity wildfires. On the ecological restoration side, suppression has also altered the historic fire return intervals. So fire is a natural part of most of these ecosystems. But these long periods without fire is really changing sort of the dynamics, the ecological dynamics. And so by returning fire sort of and approximating these natural fire return intervals, we're improving the health of forests, the resiliency in the face of future wildfire, as well as the diversity of the animals and plants that are in them. And just here, we're not looking at this specifically in the prescribed fire monitoring program, but prescribed fire has a number of additional benefits, including management objectives. It's used a lot in timber. It's used a lot as part of cultural burns for Native Americans and part of their tradition. So it's not just within these risk reduction and ecological restoration contexts. And so we're trying to understand, this is a data-driven program, a monitoring program, and we're trying to understand how prescribed fire works and sort of be most effective across a range of different forest ecosystems. So here is sort of a schematic of the western slope of the Sierra Nevada and the different ecosystems. And then you can see sort of on the right-hand side, you know, how the precipitation and temperature and fire season length change across these systems. And so the challenge is to develop a quantitative understanding of prescribed fire as it applies to these different forest types, to stands with different fire histories, and a range of different conditions. And so just to show this sort of the departure, so this graph, on the left-hand side, the orange is the high severity fire, and so all those bars that are underneath the green arrows, that's the pre-Euro-American settlement pattern as best we can reconstruct. And you can see that prescribed fire overall is about 7% across the different forest types and ranges. But then those next two bars in each little triplet of forest types shows how much in general high severity fire has increased. And you can see that this is the region on the right-hand side, the map that this applies to, and some of these large high severity fires that basically are disrupting what would more normally have been more heterogeneous burn conditions. And so the monitoring, the goals of the prescribed fire in general are to correct and reverse the effects, in this case, fire suppression, in some cases, much more than 100 years of fire suppression and exclusion, reducing tree density in overgrown stands, and start to favor larger diameter trees, open up forests more so that fire can't pass through them as well, reduce surface and ladder fuels, disrupt that fuel continuity that I mentioned earlier, and that promote really this mixed severity fire and more structural heterogeneity that provides niches for a range of plants and animals, and not these kind of homogeneous, vast, high severity landscapes. Returning fire to the frequency of historic levels, or at least moving in that direction. So often it takes a number of entries before we can really restore fire and introduce it in the way that was historically the pattern. And so these are the objectives of prescribed fire in general. So the monitoring program's goal is to use data and to basically collect a portfolio of sites across these different veg types with a range of histories, as well as treatments. It can be mastication, previous prescribed fire, thinning, to see how we are progressing towards these goals of restoration and risk abatement. So specifically, some of the getting a little bit into the nitty-gritty of some of the variables we're looking at: the fuel consumption and changes in structure, mortality and regeneration. Specifically looking at the species composition, the mixes, the relative abundances of mostly plants. It's not our main focus, but we are also collaborating with the Air Resources Board and recording smoke on impacts during the fires when they burn, so that we can improve the modeling there. And really one of the most exciting ideas of this program is this long-term goal. And so while it's a 3-year initial program, the idea is to get many years, decades even, of data, so we can see sort of how these forests are changing after 2, 3, 4 fires, and starting to get on track, and how that varies under different conditions. And so the types of fire, mostly we're focused on prescribed fire, which is this low to moderate fire severity fire that's introduced, set on a given day under a given set of prescribed conditions. Looking at, again, cross vegetation types, trying to collect data on the range of different stands age, with different burn histories and different geographies. It's also very dependent on burn windows and available resources. So, for example, last fall we didn't get a single burn in because some combination of either bad fire weather or all the resources were out. Firefighting resources were unavailable to give us backup support. The other type, which we've got so far one example of is in our portfolio, is resource benefit wildfire, also called wildland fire use. And this is where naturally ignited fires, usually lightning strikes, are burning in areas that are just where fire suppression, where we desire return to fire, and the conditions are such that we can basically manage this wildfire for the same outcomes. And so these are complementary to prescribed fire. They're limited by the opportunities. So these can basically, you need an ignition and you need moderate conditions so that it won't get out of control. But it has some benefits. It allows you to potentially burn during times of the year when you wouldn't necessarily with prescribed fire. There's potential for high acreage. Potentially, you could have some cost savings, though. It can also, depending on sort of where it's located, it can also exceed the cost of prescribed fire. But the main downside is that it's unpredictable, both in terms of when it will happen and whether or not there will be the personnel and resources available to be able to support a resource benefit burn. And then those other two groups of prescribed fire that I mentioned: cultural fire with Native Americans and resource management, which are not part of our program, but are generally smaller scale, usually for specific management objectives. So for opening up meadows, or for acorn or fiber production, or timber stand improvement. And so generally our approach is we want to come and collect data before the burn. We want to be there and look at how the fire's behaving during the burn, and then come back afterwards and see how well the fire met its objectives. So before every prescribed fire, there's basically a set of objectives drawn out, how much fuel consumption you want, how much mortality you want, as well as a year after or multiple years after to look at regeneration and delayed mortality. So how this works generally, we ID a forest site that's slated to burn through our partnership network. We're not burning the fire, the landscape so much as we, Forest Service or the Nature Conservancy or state parks. We're getting word that there is an area that's coming up for a burn. Based on that, we look at the stand history, we look at the spatial configuration, and we come up with a sampling design. And then we deploy our field crews to conduct a common stand exam and put in these permanent plots with rebar, permanent markers, and tag trees to collect a bunch of that data that I mentioned. Either at the burn, that's ideal. It doesn't always happen, but we've increasingly got more and more of our people that are red card certified on our crews, so we can be there to measure flame height, rate of spread, and really consider have the data to show why a burn met objectives or didn't meet objectives, depending on the weather and how the fire behaves. And then, as I said, to return after the burn, both in the short term, a couple weeks after the burn, to look at to measure some of these more transient variables, such as forest fuel consumption, and then come back and look at a year later to look at mortality, fuels, regrowth, et cetera. And here's just an example of two burn plot designs, sort of sampling designs. So on the left-hand side was a prescribed burn in the Stanislaus National Forest, and you can see sort of nice, even location of plots where those little stars are based on differences in the stands, as well as the fire histories. Because everything is basically, it's like a, you know when it's going to happen, and you can plan well in advance. On the right-hand side is the Springs Fire, one of the resource benefit wildfires, where we got it was a great opportunity. We got a call just as the fire was taking off that, hey, it looks like we can manage this. Can you come in and put some plots basically ahead of the flames? So we, cooperating with the Union National Forest, we got a history of the prescribed and wildfire burns on the site. Went in and our field crews were basically running ahead of the flames, putting in plots, waiting, watching, and then coming back afterwards and collecting some data. So that was an exciting opportunity. But you can see it's not quite the storybook plot design, at least spatially, that the prescribed fire was. And so this is, we're basically coming up on our second birthday here in the program. And today, this is where we have put in plot networks across most the Sierra Nevada. There's one up there in the northern part of the state in the Modoc. But you can see from this, basically with the unburned sites in blue and the burned sites in either red or pink, that one of the issues is not everything is getting burned. And so while when we sign up to do a site, basically the idea is that, okay, this fall or next spring, we're hoping to burn here. The conditions don't necessarily cooperate. And in fact, they often don't. And this is just part of the nature of the beast. But it is a limitation in sort of, especially in short term, a 3-year window of grant cycles that you want to be able to show results. And so I'll talk about a couple of the reasons why it's difficult to get the burns done, but it's something we struggle with. And this is just sort of an example of sites. Everything that's got an NA there is basically a site that we weren't able to burn yet. These are our different data collection sites. But when you can see that graph on the upper right. This is the Springs Fire, where you can get some real potentially nice quantitative data on how things like the duff and litter depth are changing as a result of that fire. And that the picture down there is the actual a picture from the Springs Resource Benefit Fire. So you can see that we necessarily know what your images of sort of controlled wildfire are, but that's very very low severity and very mild, and was actually had to be encouraged in several places to keep going. And so, so one of the main challenges is also, even when you do get to burn, can you burn hot enough? Can you, because we're being more conservative and we don't want fire to escape us, often one of the problems is whether or not we can get enough of a burn or enough severity or heterogeneity. So looking at this as sort of a big picture, prescribed fire, and are we able to sort of come up to the pace and scale that we have the mandate for? The state is making a number of efforts on this behalf. There's the recently signed shared stewardship agreement with the state of California and the USDA Forest Service, where there's the agreed upon goal of 1 million acres of treated forests or rangelands annually by 2025. And so that I'll talk about in a second, but one of the reasons to think about monitoring that is it's not just about quantity, it's also about quality. So what are those acres, and what gets counted towards that 1 million goal? And then there's this recently published California Wildfire and Forest Resilience Action Plan, which is a really neat document and very encouraging. That it's thought about a lot of about these problems from a lot of different angles, and has a number of sort of a multi-pronged approach to how we should think about this, which is really what is needed. There's definitely no silver bullet. But this map on the right side of the slide really shows you the scale of the problem, where these are fire return intervals, and everything in blue tones is basically a departure from fire from the natural fire return interval. It's overdue, basically. So it's overdue for burn, and in many cases, it's 2, 3, or more times the normal burn interval has gone by since the last fire. And so there's a huge backlog of acres for which to that really need some sort of treatment or reintroduction of fire to come back to its normal sort of ecological state. Assuming we know what normal is, depending on how climate change affects that. But anyway, it gives you a sense of the scope of the problem and how much area. And so we're looking at, that's probably in blue there. I'm guessing that's upwards of 40 million acres. And we are treating about 90,000 acres with prescribed fire a year on a good year. So we've got a ways to go. Going forward, just the prescribed fire the monitoring program itself, as I said, it's a pilot program. So basically we're demonstrating to people how to do the monitoring and the qualitative analysis that comes from it. We want to increase partnerships. So there's a whole lot more than that list I gave you. Expand the geographic scope beyond the Sierra Nevada, especially in the Coast Range. Increase technological capacity, the interdisciplinary nature, as well as the publications, and we would like to have a lot of people using the data we're collecting, so we can broaden sort of the learning and the lessons, and give feedback to the participating forest managers. So all those partners we have are not just doing it out of the goodness of their heart. They really want specific input on their own forests and the state of sort of fire in their forests. And finally, on the sort of the bigger scope of prescribed fire in general going forward, to meet this pace and scale, I've kind of divided this into sort of 3 sections. So we really need to increase collaboration and cooperation. So it's state and federal governments. We're talking over 60% of the forest lands in California are state and federally owned. And so a lot of that management, there's got to be a lot of cooperation on those lands, and it's kind of and a movement towards really sort of integrating prescribed fire and fuels treatment more regularly on the government, as well as with government. We need collaboration with government and private NGO, tribal partnerships, as well as without the government, but sort of the NGOs and the academic institutions with these same groups. And PBAs is the Prescribed Burn Associations, which is a potential very powerful sort of association of landowners to implement prescribed fire. We want to improve our readiness in general, so that's defining and prioritizing where the burn areas, where the areas that really need to burn are, and in those places, making sure that we can streamline and expedite sort of the permitting processes and some of the liability concerns that keep burns from happening. We need to improve training opportunities so we have sort of a whole lot more people and groups doing prescribed fires. And then really real necessity is to create a dedicated workforce and prescribed fire implementers so that they're not getting cherry picked whenever there's a wildfire, and to have those careers sort of be on parity with the rewards and sort of the benefits of firefighting, which is not currently the case. And finally, as I said about the 1 million acre shared stewardship, we need to make sure that the fire that is going on the ground is quality and it's effective at doing what it's supposed to be doing. And so in order to know that, we need to be monitoring the effects of the fire. And so this program would really be ideally be replicated privately through nonprofits and government, so that lots of people are using sort of a consistent and standardized monitoring program to ensure effectiveness. And so that we can use that to basically managers and research can improve the state of the art of applying prescribed fire. And I've gone a little over, but with that, I want to thank especially Hugh Safford in the Safford Lab, Ashley Gruppenhoff, who's been in the trenches during this whole program, and Joe Rosano, especially my counterpart at CAL FIRE, as well as the other members of the FRAP leadership at CAL FIRE. Thanks.
Great, thank you for your presentation, John. I will get to the questions in just a minute. I did post a link to a survey. If you have a chance in the audience to fill that out, it takes just a couple of minutes and helps us, gives input for future webinars and helps us report back to our funding organization. So if you have a chance, it'd be great if you could just take a minute to fill that out. Just a couple of questions. So John, our first question is from Patrick Doyle. They ask, is your California Prescribed Fire Monitoring Program coordinating with the Fvet, which is the Fire Behavior Assessment Team, in any way? More specifically for the wildland fire use or wildfires being managed for multiple objectives?
Good question. We are not. So far, the wildland fire use has been basically a minimal sort of slice of what we've been doing, but we would like to. Basically, we'd like to increase it, and we'd like to be on more people's sort of Rolodex as far as knowing when those fires are occurring, and that's a motivation for me to actually reach out and see to make connections with FBET, because that would be a good way to leverage the program. Thank you.
Great. And then from Christina Galitsky, is there still a lot of, or even some, resistance to prescribed fire from the public or other organizations? And how do you respond to those challenges from other organizations and garner support?
So there probably is. We're keeping busy enough with people that want to do prescribed fire, and there's enough of a backlog as far as people who've wanted to burn and conditions not being optimal, and they're kind of, they've got a buildup of places that need fire, that we haven't run into sort of any wall so far as you know, we're not knocking on someone's door asking them, can we burn here, please? And they're saying no. It's with our capacity of basically 1 or 2 field crews, we've got more than enough work. But as far as statewide, there certainly is, and especially in the wildland urban interface, there's a need, to sort of get people thinking about it, but the other, not just those fire in and around where they're living, but the smoke impacts. And so this picture kind of being apropos on the background is fires get shut down all the time. Prescribed fires get shut down just before they're about to start, or a couple hours into it, or minutes into it, based on air districts and complaints. And so getting people, one of the main challenges sort of to come up to scale will be to address the smoke impact issue, and some combination of managing it, better modeling for it, but also getting people to accept some level of smoke. So a little is better than, for example, last summer's sort of inundation of horrendous air quality.
Okay, thanks. So I know we're at time here, so if people need to leave, feel free to do so, but we'll ask John a couple more questions before we close out. Our next question is, are you using any of the data from federal fire ecologists on similarly designed monitoring projects? And what are the implications of this study beyond increasing prescribed burning?
Sorry, could you repeat the first part of that question, Allie?
Are you using any data from federal fire ecologists? There's extensive data sets out there on similar projects for the Park Service or Forest Service. So are you using any of that past data for this project, for projects that were designed in similar ways?
We are. I mean, we're not using that data. How do I say this? So part of our work is looking at severity across, for example, the California or the Sierra Southern Cascades landscape. And so we're using federal data as far as that to understand what's happened in the past. But we're not using. So there's a number of different sources, and certainly the ravage data, and this 40-year study we did on severity trends. Most of that comes from either federal or for CAL FIRE. So CAL FIRE has a number of databases that we use, but we're not using it per se in the actual sort of in our portfolio of sites very much. And then the second part of that question was, remind me, it was
implications of the study beyond prescribed burning.
Yeah, well, so one of them is trying to get this data back to the specific forest managers that are on the sites where we have put in plots, and then the other is more of a writ large sense of what extent is prescribed fire helping restore fire return intervals and reduce fuels at sort of at larger scales. Fires at this point in time are 300-acre fire in California is big. Other places are 1,000-acre fires in Australia, or for example, in the amount of acres that are burned in Florida, we pale by comparison. But we're certainly, I mean, it's part of that's part of the idea of the portfolio, is it can be used for a whole range of sort of data and research implications.
Okay, and unfortunately, we're out of time, but our final question that we'll be able to get to today is, how are you balancing or prioritizing burning and monitoring across different ecosystem types? Is there a way or a plan to incorporate monitoring or training into the new PBAs or other private burn projects so that people can submit their own data?
That's an excellent comment, and we have not yet sort of considered how to open it up to submitting, but the training part is definitely on our sort of our docket. And how do we get, especially working with our partner organizations. So the idea is that our partners, for example, the Nature Conservancy or the Forest Service, would be collecting the same kind of data we're collecting, and would basically dedicate some of their resources towards that. We are working a little bit, for example, with Lenya Quinn Davidson and talking about how can we sort of leverage all the resources of PBAs. And so that would be one of the ways to do it. But it's definitely, you never know how long, even though we call it a long-term project, we never know how long it'll be. So the importance of sort of passing the baton and getting other people to collect data is very important. And luckily, I mean, that's part of the rationale for using the Common Stand exam is that we're using a protocol that is well known, that's well documented, that it's not archaic by any stretch. And so it's easy for people to get their hands on sort of the same tools and approaches we're taking. And just to finish, if you have any additional questions, my email's right here on this slide. So I know we're out of time, but feel free to email me, and I will try to respond to you as best as I can.
Great. Thank you so much, John, and thank you to Mark as well, and to all of you who attended the presentations. Our next feral lecture will take place on Wednesday, April 14th, also at 3:30 p.m. It'll be a discussion about native insects and diseases of the true firs by Beverly Boulon from the Forest Service. We'll have more information about that posted on the Fire Science Consortium website as soon as the details become available. So thanks once again for those great presentations.